All right, hello everyone. So in this video, we're going to be talking about textures and materials and the differences between the two and how kind of they work together. Okay. So for this, I want to create a new level. So we're going to go up to here to File, New Level, and then under the kind of the templates they have here, I'm going to click on Default, and let's go ahead and save that. And delete that guy by just selecting it, hitting Delete key. I'm going to add a plane to the level. And I want to change the scale. I guess that doesn't need to be 10,000 by 10,000. So we have a really, really big plane here. And this will make sense in a minute. So let's open up the content browser. And here I have a material and I have a texture. Okay. So let me double click this texture. Now, in this case, this is a normal map. So this is a bunch of depth information that the engine is able to use to kind of simulate a detail where there isn't actually any detail. Many of you should have gone through grade 201 and 202, so the 3D modeling and animation and digital sculpting. Digital sculpting is entirely based around normal maps, so you're going to be going into Mudbox, sculpting out your models, and then extracting that normal map, and this is basically the result of that, right? So this is what you're actually generating as a normal. So in my case, this is just kind of a rough water normal map here. So this is a texture, okay? A texture is something that a material, or also sometimes referred to as shader, uses to kind of project an image of something onto another object. Okay? So in my case, I have created a material here where I'm utilizing this texture to create an effect. So let's open up my material here and we'll take a look. So here we have a base color. Okay, the base color is just that, a base color. Usually this will be a diffuse texture. So this is where all of your color maps come into play, where you hand painted textures in Mudbox in digital sculpting, or you used images from online and applied them to the UV coordinate image to create that. This is essentially what that is. So if you had an actual texture with colors and stuff on it from your UVs, that's what you would plug in here. Metallic is basically how I'm getting this reflection on this previous sphere here. The higher the metallic value, the more reflectivity you're going to get. So this is between a value of 0 and 1 typically. So I'm using a constant here with a value of 0.4. So I'm kind of a little bit below the middle because I don't want it to be too reflective. And the metallic kind of coincides with roughness. So you won't really get any reflection if you have a decent value in roughness. So to make sure that I'm getting a pretty good reflection, I put my roughness to 0. I don't really need anything in specular because the metallic here, the specular defaults to 1, or 0.5, excuse me, defaults to 0.5, so it's right in the middle. And then my metallic here is having that reflection, so I don't need too much more specular. If I did, it might get overwhelming, especially with like bloom effects and stuff like that. You don't have to worry about that one, but to hover over it, it's the material roughness is how anisotropic. Don't worry about it. Emissive color is also known as incandescence in like Maya. So this is the glow that the object has. Opacity is the translucency of the object. So right now I'm actually using a really cool node called a depth fade. This is a node that you can pull up right here in the material editor. So you just right click and you can type in whatever you want to get, and you'll see depth fade right there. So basically what this does is it creates opacity when objects are close to it. So if we're creating, a water shader, for example, and we have kind of a beach where the landscape is gradually coming up and the water's coming to it, it's going to get more translucent the closer the surface comes to the water surface. Right? So that's essentially what that's doing. And then here's our normal. This is where I'm actually utilizing my texture. So I brought in a texture sample right here, and then you can choose the texture that you're using. So here's a grass. Here's some grass textures I made before that I'll show you in a minute. So I have the water normal that I showed you just a minute ago, right here, and right here. So I have two of them. And what's happening here is I'm using a panner node, which actually, like, quite literally pans the texture in whatever direction I have these values at. So 0.02, it'll move 0.02 in the X direction, negative 0.04 in the Y, and then this one's kind of opposite here. And that's how I get this movement here, because these textures are essentially infinitely tiled upon themselves. So the more you have it tiled, the finer the details are going to be, and that's how you're getting this movement here, these two nodes. And then here, I'm quite literally just tiling it to make it smaller. So I'm multiplying my texture coordinate by a scalar parameter called tile, and I have the default value set to 10. So essentially, it's multiplying this texture 10 times. So, here's one texture, and then 10 times it's making that one big texture really small and then duplicating it like that. So picture all of these little boxes as the texture as well. And this goes 10 by 10 if you have it set up like this, because the U tiling is 1, the V tiling is 1. So I'm multiplying that. 1 times 10 is 10, of course. So it's essentially making this 10 by 10 right here with this map. Okay, world position offset will give you movement in the material. I'll actually show you that in a minute as well. Displacement is for material tessellation. So it, in a way, creates geometry for the material, which can then be manipulated within the material to create some really cool effects. Subsurface is typically used for foliage. When you shine the light on a flashlight, you can see the light from the other side. That's subsurface. So that's called subsurface scattering, where the light kind of scatters within it and creates a glow. That's what that's for. Ambient occlusion, self-shattering in crevices and stuff like that, makes objects pop more. And refraction, index of refraction of the surface. So how much light is it going to refract? Okay. So once you're done working with a material, you always want to click apply. This will compile the shader, so it's ready to be used within the actual game engine itself. Okay. All right, so that went ahead and finished up.